Hello friends, in today's question, a small block of mass 0.1 kg lies on fixed inclined plane PQ which makes an angle theta with horizontal. A horizontal force 1 Newton acts on the block through its center of mass as shown in the figure. The block remains stationary, so we have to find out value of theta for which the block will be remaining stationary. So this is a block. A horizontal force 1 Newton is being applied on it towards the left side, and this inclined plane is fixed. Okay. So first of all, let's draw the various forces which will be acting on this inclined plane, the box. So this is angle theta, and we have inclined plane at the block of mass 0.1 kg. The downward direction we are going to have mg, which can be divided into two components. This will be angle theta, so we are going to have this as mg sine of theta, and this will be mg cos of theta, and there will be a normal in the upward direction, and a horizontal force is being applied towards left, that is of 1 Newton. This horizontal force can also be divided into two components. So this angle will be theta, so we have this will be our 1 cos of theta, and in this direction it will be 1 sine of theta. And let's suppose that it is trying to move in the downward direction, so we are going to have a frictional force Fr that will be acting upward direction. So these are respective forces which will be acting on it. Therefore, as the block will try to remain stationary, okay, you can say the block will try to remain stationary if all the forces with respect to the inclined plane are in equilibrium. So we can say our mg sine theta is equal to cos of theta and plus frictional force Fr. We can find out Fr. If mu is the coefficient of friction, then Fr will equal mu n, and n will be equal to sine theta plus mg cos theta. Sine theta plus mg cos theta. From here we can say that our Fr will be equal to mu sine theta plus mg cos of theta. And if we substitute this value, let us call this equation 1 and this as equation 2. So from equation 1 and 2, from equation 1 and 2, we get mg sine theta is equal to cos of theta, substituting value of Fr, that is mu, sine of theta plus mg cos of theta. So let us rearrange the equations. So we get this as cos of theta plus mu sine of theta, cos of theta plus mu sine of theta is equal to, we can take mg common, and this will be our sine of theta minus mu cos of theta. And from here we can say that cos of theta plus mu sine of theta divided by sine of theta, minus cos of theta is equal to mg. Mass is given as 0.1 and g is 10. So 0.1 into 10, this will be equal to 1. So it means cos of theta plus mu sine of theta divided by sine of theta minus cos of theta is equal to 1. So if the value of coefficient of friction is 0, say for mu is equal to 0, we get cos of theta divided by sine of theta is equal to 1, or from here we can say that tangent of theta is equal to 1, or this means theta is equal to pi by 4. So value of theta is our pi by 4, and under this condition the block of mass 0.1 kg will be in equilibrium even in the absence of the friction. You can say from here, for theta is equal to 45 degree, the block will be stationary even in the absence of friction. So it means now if theta is greater than 45 degree, this mg sine theta component will increase and the friction will be acting in upward direction and block will try to come down the inclined plane. You can say for theta is greater than 45 degree, mg sine theta increases, therefore friction acts towards point Q, towards point Q means up the inclined plane to keep the block stationary. To keep the block stationary. So this completes the question. Thank you.